the noted astronomer, was writing a science fiction
We talked about Carl Sagan previously.
script called Contact, meeting extraterrestrial life form.
And he's the guy behind the novel Contact that later became the movie.
But he had a problem. The distance between stars is so great that it would take centuries to visit other planetary systems. And because of the time dilation problem, he decided to ask a physicist, is it possible to go these enormous distances in a twinkling of an eye?
Sagan called Professor Kip Thorne, a noted expert on Einstein's theory. Thorne struggled with the problem for some time. Then, in the back of the Ford Bronco, as he was driven along Interstate 5, he made one of the most inspiring connections of modern physics by linking Carl Sagan's cosmic conundrum with the exciting new concept of wormholes.
A wormhole is a hole in space that may give us a shortcut between 2 points. For example, if I had a super microscope and I could peer right into the fabric of space and time, I would find that it's not smooth at all. It's foamy, it's frothing, with tiny little holes and bubbles. If science can somehow tease apart one of these holes in space, we can actually connect two distant regions of space and time. Now, where have you seen that before? In Alice in the Wonderland's Through the Looking Glass. The wormhole was Alice's looking glass that connected the countryside of Oxford with Wonderland, such that when Alice stuck her hand through the looking glass, her hand went through the wormhole and came out on the other side of forever.
Thorne was triumphant. Wormholes were an exhilarating means of connecting 2 points in space. It was only later that the full implications hit him. If wormholes could cheat space, they could also cheat time.
All right, so who came up with the idea of time travel through wormholes? Kip Thorne. And this happened because of the novel Contact. All right, so only if the space-time continuum is curved, you may be able to take shortcuts through wormholes. What are wormholes? Wormholes are these theoretical shortcuts through the space-time continuum. All right, so is there anything that may give us wormholes in nature?
Going forward in time at near the speed of light is relatively easy. Traveling backward in time seems all but impossible now, but it isn't ruled out by Einstein's theory. If Joe Tanner in his super shuttle wanted to go back in time, he would have to locate a black hole. And not just any black hole, a special black hole connected to another light years away. The resulting tunnel in time and space is called a worm.
All right, so what are these wormholes? Do we have black holes today? Yes. Did we have black holes yesterday? Absolutely. Do you think we're going to have black holes tomorrow? Yeah, if the future, the past, the present all happen at the same time, if these black holes become connected, they will become shortcuts to the future or to the past. All right, so these theoretical shortcuts are known as wormholes. All right, so pick out the best answer.
E.
Okay, so who's the author of Contact?
E? I wasn't clear.
C.
It's going to be C. It's Carl Sagan. Very good. Those of you guys who pick C, give yourself 2 points. So who's responsible for the theory of time travel through wormholes?
B.
That's B.
B. Kip Thorne. All right, those of you guys who said B, give yourselves 5. Those of you guys who picked B, give yourselves 2 points for each. All right, so let's talk about the possible existence of these wormholes. All right, in theory, that's possible. If a black hole from the present becomes connected to a black hole from the future or the past, obviously, theoretically, you have your wormhole. Except these kind of wormholes will only last for a fraction of a second. That's the chance connection. And even if you knew that there was a wormhole, and there's no way of telling by looking at a black hole from outside, even if this were a wormhole, what are the chances that you're going to be able to do time travel? Number one, opening at the center is going to be infinitely small. Depending upon the connection points, the throat may be large enough for you to be able to go through, but the gravitational tidal forces would just shred you to pieces, not to mention the radiation would vaporize you. Unless somehow you can stabilize a wormhole, there's no way you can do time travel. So how can you actually stabilize a wormhole? What you need is something that generates with positive gravity. When Kip Thorne came up with the idea in the 1980s, he said, you need something that can generate with positive gravity, and he called that something an exotic matter. All right, there was no such thing in physics in the 1980s. In the 1990s, we discovered that the universe was expanding, no surprise. But we also discovered that the universe was accelerating while it was expanding, which means that something was pushing the universe in the upward direction. There was some kind of a repulsive gravity which was being generated within the universe, which was responsible for the acceleration of the universe during the expansion process. All right, we don't know what that is, and we don't know exactly what that thing is that generates repulsive gravity, and that's the reason why we called it the dark energy. All right, so what you need is exotic matter that would generate repulsive gravity in order to stabilize a wormhole so that you could do time travel.
Suppose a wormhole does twist time as well as space. Suppose NASA engineers were able to keep 2 wormholes open and connected using a repulsive gravity source. Suppose the super shuttle could navigate through the connecting tunnel. Suppose they found Elvis out there. Suppose. Cosmologists do a lot of supposing.
Now, one of the theorems that was proven many years ago is that if you create a wormhole in a region of space where it never existed before, you must also twist time in such a way that time travel becomes possible. In other words, not only do you have created a hole in space, you must also have twisted time around so that it becomes possible to return to your starting point in space-time before you left. You automatically create a time machine when you create a
So only through wormholes, shortcuts through the space-time continuum, you can travel to the future as well as the past. So let's get back to the same question. Can you travel 100 years into the future, spend 18 hours there, and come back in the next fraction of a second? Absolutely. Only through wormholes. It makes it possible. All right, so forget about going to the future because we don't know what happens in the future, but we have the map of the past. If I have to take a vacation, it would be a lot more interesting to go back to the past for a time travel vacation. So you can play with the history. How about going back into the past and finding Hitler and killing him before he starts World War II? And what happens to the present? All right, guys, don't answer the question because I've been told that I lecture above students' heads. You probably don't know who Hitler is. So instead, let's talk about you guys. All right. How about going back in time and finding your grandfather before he fathers your father and kill him? What happens to you? All right, guys, that's how time travel suicide is going to happen to you. I'll forget that. Let's get back to Hitler. How far back in time do you have to go so that you can actually kill Hitler? When he was famous, when he was looking the way he does in the pictures that you see, guys, he was so well known that he was always protected. There was no way you're going to be able to go near him. So if you're going to kill him, how far back in time do you have to go?
Go back to like World War I and just shoot him.
Yeah, or maybe even earlier than that, right? Because, I mean, if you tried to shoot him like around World War I, you're taking a risk, right? It would be easier to kill him when he was a kid. So you have to start looking for a kid named Adolf with the funny mustache. And then hopefully, as you're going through a number of them, hopefully you will get the right one at some point, right? All right, so good luck with that.
Can you just
all right, so go back to your own past. Find your grandfather before he fathers your father and kill him. Then what happens to you?
Well,
it wasn't your real grandfather.
All right, that's a possibility. So nothing is going to happen to you because just as you suspected, that's not your grandfather. What if that's your real grandfather? Then what happens? Would you vanish?
But doesn't but you had to go back in time in order to kill him. So what? There's a paradox, isn't it?
Okay, so Alec, you're thinking, wait a minute, let's think about logic. And you guys are used to logic because everyone is an engineering major. 2 + 2 is going to be 5 - 1. Anyway, so what are we dealing with? So you go back in time, you kill your grandfather before he fathers your father.
But in order for that to happen,
and then what happens is, logically speaking, you should vanish, right?
Well, then there's a problem.
And then no one goes back in time and kills him, and you still exist. And then you go back in time again, you kill him, you vanish. Then again, no one goes back in time and no one kills him, and you're born again and you still exist, right? So all of a sudden, you have 2 logical conclusions which are in 100% contradiction, right? That's known as a paradox. Got it? So the act of time travel is going to give you these paradoxes. These are known as grandfather paradoxes or grandfather paradox. So how do you overcome that? So if this is the argument against time travel into the past. Nathan is the one who mentioned that. He said, hey, I don't believe in it because if you go back into the past, obviously it's going to create all sorts of problems. So how do you overcome this paradox? There are 3 ways you can overcome it. Number 1, you can say time travel into the past is impossible. Or you can say, yeah, you can go back into the past, but you're not going to be able to kill your grandfather. I don't know what's going to prevent that from happening. Or the third one that we need is the act of time travel needs to create its own parallel history. Got it? So that now it looks like the time travel in the movies. The only way you can go back into the past is the act of time travel needs to create its own parallel history. All right, so if the past, if Einstein is correct, if the future, the present, and the past happens all at the same time, if nothing prevents you from going to the future, nothing should be able to prevent you from going to the past either. The only way you can overcome the grandfather paradox or the time travel paradoxes, the act of time travel should create its own parallel histories or the parallel universes. So that becomes the third condition that needs to be satisfied. The condition number 1, the time needs to be a continuum. Condition number 2, the space-time continuum needs to be curved so you can take shortcuts. And the condition number 3, the act of time travel needs to create its own parallel histories.
Is what's called the grandfather paradox. The grandfather paradox says If time travel is possible, then it ought to be possible to go backwards into time and kill your grandfather before he fathered your father. Then you've got problems.
You might tend to vanish if you shot your own grandpa, but Tipler says that quantum mechanics provides a theoretical solution. Quantum theory holds that each atom goes through all possible histories. Tipler asks us to think about such a universe, or multiverse. He supposes you would have killed a copy of your grandfather in another branching universe.
In that history, which you're now in, he does not father your father. You do not exist in that history. As a young man, anyway, what you have done is you have entered that history via the time machine. Now, if we could isolate ourselves, we would also be aware that we exist in many of the universes. It's the very fact that we are, so to speak, anchored to one of these universes, because we are interacting all the time with the other atoms in this universe, that we're unaware of the other universes.
Believe it or not, this is a version of quantum theory. All right, just pick out the best answer first.
E.
Okay, Ian, did you say D? It may be true in your case. Anyway, so B is the
I
best
should
answer.
have. I didn't read that far.
Okay, because D is the one that fits your scenario. All right, the only way you can prevent this grandfather paradox is the act of time travel needs to create its own parallel histories. In fact, there's a version of quantum theory, which this guy created. His name is Hugh Everett III. And this is known as the Meta-Worlds interpretation of the quantum theory, which was published in 1957. And this guy was a PhD student of John Wheeler. We discussed John Wheeler. And another person who got his PhD under John Wheeler was Kip Thorne, obviously. All right, so Hugh Everett publishes his version of it. At the time of this theory was published, he was the only one who believed in this interpretation of the quantum theory. Today, this interpretation is the mainstream interpretation of quantum theory. All right, the competing theory is known as the Copenhagen interpretation, which persisted until recently, but most physicists decided to switch to Hugh Everett's interpretation of quantum theory.
I've heard that there's a possibility that in string theory there are multiple universes being created at any single moment.
It's an idea that comes into the theory, also comes into theories of cosmology.
Should there be multiple us at this moment?
There's a theory that says something akin to that we are having an interview in the other universe. The interview is different in these other universes.
In some of the universe? Could I have nailed you just now?
I just heard that you did from the other one.
Oh, really?
Yeah.
Maybe I nailed you in this universe.
You did indeed.
Would you please come back?
Sure, yeah,
Maybe I'll understand it next time. Brian Greene, we'll be right back.
Brian Greene is the face of the string theory.
On Nova, take a thrill ride into a world stranger than science fiction, where you play the game by breaking some rules, where a new view of the universe pushes you beyond the limits of your wildest imagination. This is the world of string theory, a way of describing every force and all matter, from an atom to Earth to the end of the galaxies, from the birth of time to its final tick, in a single theory, a theory of everything. Our guide to this brave new world is Brian Greene, the best-selling author and physicist.
No matter how many times I come here, I never seem to get used to it.
Can he help us solve the greatest puzzle of modern physics? Our understanding of the universe is based on two sets of laws that don't agree. Resolving that contradiction eluded even Einstein, who made it his final quest. After decades, we may finally be on the verge of a breakthrough. The solution is strings. Tiny bits of energy vibrating like the strings on a cello. A cosmic symphony at the heart of all reality. But it comes at a price. Parallel universes and 11 dimensions, most of which you've never seen.
We really may live in a universe with more dimensions than meet the eye.
People who say that there are extra dimensions of space have been labeled crackpots or people who are bananas.
A mirage of science and mathematics? Or the ultimate theory of everything?
If string theory fails to provide a testable prediction, then nobody should believe it. Is that a theory of physics or a philosophy?
One thing that is certain is that string theory is already showing us that the universe may be a lot stranger than any of us ever imagined.
All right, guys, so this is just a preview for modern physics. All right, so the three conditions need to be satisfied for time travel to be possible. Time needs to be a continuum, which means that the past, the present, and the future all need to happen at the same time. And according to Einstein's theory of gravity, they all happen at the same time. So we'll check to see if the theory is correct. So that's the next thing that we will do. Space-time continuum needs to be curved. If it's flat, time travel is not possible. If it's curved, kind of like the Mobius strip, we may be able to take shortcuts. And the last condition that needs to be satisfied is we need to have alternate timelines in order to overcome the grandfather paradox or the time travel paradoxes. All right, so the only thing that we will address is Einstein's theory of gravity. That's what we're going to look into during the next hour. All right, the rest of them will be part of modern physics.